Hear me out. It may feel overwhelming, the prospect of dealing with all of these issues in a city like San Francisco, but I don't think it has to be. With some open source software and a single drone pilot, we can find all of the trash piles in the Bayview neighborhood within about 20 to 30 minutes. From my rooftop, I can fly this drone around my entire neighborhood. I can face the camera down so that it's viewing the ground. And as I fly over the streets, I can snap pictures every couple of moments. It's like a couple pictures a second. And as I fly over all the streets, I use the map that comes with the drone's software to see where I have covered, which streets I've gone over. Once I'm done covering all the streets, I simply come down off the roof and plug in my drone and offload the photos. This is where my web application comes in. You can check it out at www.westcoastdynamics.com, link in the description. I upload the photos through my web application, which kicks off a trash identification pipeline. The pipeline processes each photo that I upload. And for each photo, it will resize the photo to a square dimension, 2048 by 2048. Every photo that comes out of a DJI drone has a bunch of metadata attached, including latitude, longitude, rotation, tilt, angle, speed. At each stage of image processing, the program is copying the metadata in the photo into each new photo that's created so that that's passed along and not lost. It's going to come in handy later. The pipeline moves that processed photo into a new S3 bucket, and that S3 bucket is where the AI pipeline is listening to start processing and looking for trash. The AI pipeline runs my trash detection model on each photo and saves the trash pile detections in a database. A post-processing step then takes each of those detections and uses it to pull out an aerial photo of each trash pile and save them in a final S3 bucket where they're available to my web app. These detections and the associated photo of the trash pile from the air can now be displayed on my web app, where I can go and select them to be cleaned up or ignore them. I can also view the trash detections on a map to see the distribution around my neighborhood, as well as zoom in and actually see what the trash looks like on the street at the location where it is. I'm using Amazon Web Services for my AI pipeline. I uploaded my dataset to Amazon's recognition service with a K, and it trained and deployed my model. I want to let you in on a little secret. I don't actually know which architecture my model's using. That's because I elected to use Amazon's recognition service to do all of the training, testing, and deployment of my model. Don't get me wrong. I initially did set out and use models that I selected myself. I trained them on my local machine. I tested them. But at that phase, I was just trying to figure out if this would work at all. Once I realized that my dataset was good enough to detect trash piles, I sought to productionize my model so that I could run it on a web application like I am now. And I looked at what Amazon Web Services has to offer. I tried to upload my existing model architecture, like the weight files that define my model's current state. I tried to upload those to Amazon's recognition service and SageMaker, but they just didn't work. There were too many little incompatibilities in the architecture's specifics for them to work. I also went down the rabbit hole just a little bit of trying to run a custom detection model on Amazon services, but I found that that was kind of a waste of time because I wouldn't really get all of the benefit of what Amazon's recognition service or SageMaker service have to offer. So finally, I realized that I could just upload my really good data set to recognition and have it train its own model. That model would be in its own architecture, so therefore it would work across all of the different platform niceties that they offer. And that's what I ended up doing. And the results came out just as expected, just as good as they were when I was doing this on my own machine in development mode. But this time it is productionized and it's available, highly available on Amazon for me to control and use in my pipeline. So there you go. I hope that helps you understand a little bit of how I productionized this model. Now I want to talk a little bit about how I'm using it. For the past couple days, I've been using my service to go out and identify trash piles and actually report them to 311. And the results have been kind of fascinating, actually. So just yesterday, I went and flew the drone. It took about 20 to 30 minutes to fly the drone, capture all of these streets in my local area, and upload the photos to Amazon Web Services through my web app. Just a few minutes later, I had results, and I was able to go through and select the ones that I thought were trash piles and file a 311 complaint. Now, if you look at the map that I have displayed right here, you can actually see on the map all of the trash piles I identified. And by my count, there were 45 large trash piles identified in my neighborhood yesterday. These trash piles aren't anything to laugh at. These are not like little bits of junk. These are large piles of garbage, bags of garbage on the streets or on the sidewalks. And I find that both appalling and fascinating. So I do really think there is a use for this because there is so much garbage out there, and I think we need to start collecting this data and really making this more public so that our community is really aware of what we're dealing with here and we can properly address it. And so that's what I'm going to be working on. I'll be flying the drone a couple times a week, maybe even every day, and putting out a data set that shows all of the trash in our neighborhood conclusively, what's out there, as well as improving my model, and I'll eventually publish out the data set for the model as well. I'll also be reporting these trash piles to 311 so that they can get cleaned up. And I'll be checking back in to see how long it took them to clean them up and whether they're getting cleaned up. Thanks for watching, and I just wanted to share with you where I'm at with this. And I'm so glad you're watching, and I'm having a great time doing this, and I hope you're having a great time learning about trash detection using drones. Okay, see you next time.